Hey, what's up, guys? This is Chung here. So today, let's take a look at another Codeforces problem, the football season. So basically, here you have like some description about footballs here. Where the we have a wins and we have several games, and we can either win the game, or we can lose the game, or we can just make a draw, right, to the game. and and you're also given like several parameters, which is the n, p, w, and d here. So which means that we have total of n games, and we have a target points, right? We want to target, and then w and d means that w means you every time when we win a game we get w points, and every time when we draw a game, right, we get d points. Of course, by losing the games, we will have 0 points. And it asks us to output the three numbers, which represents how many games we won, how many games we draw, and how many games we lost, right? And if there are multiple answers, print any of them. And if there's no answer at all, report about it, which means that we're gonna reprint -1. So more formally, basically, we're trying to solve a equation, right? Which the x times w plus y times d equals to p, and the second one is this one, right? Basically, x plus y plus z equals to n. Actually, for the second one, since it doesn't really matter how many games we lost, it doesn't really matter, because as long as this x plus y is either equal or smaller than n, that's fine, because if we can have like a formula like satisfy this two condition, this the first one plus the second one, for the remaining games, we can simply put like z's, right? We can assuming the remaining games we all lost, right? That it will not affect the final answer. Okay, and then we have this kind of like few constraints here, right? As you guys can see, the n and p, they're pretty big, right? So which means that we cannot search either n or p. But the d and w are relatively small, which is 10 to the power of 5, right? So, and when we try to solve these equations, we have to use this one way or the other. Otherwise, it will definitely TLE. Okay. And so when we do the search, right? Because to solve the equations, right, we have to do a search one way or the other. So the problem is that how can we prove that we can use this like a range to do the search, right? Okay, so first thing first, if there are multiple like answers for x and y, we want to find the answers that x plus y is as small as possible, right? Because if we find the answer for that, we can simply use that one to verify if the best, the optimal answer has this total of game equal or smaller within range of n. If it is, then we know we find the answer. Otherwise, if even the optimal answers the is has exceeded the n games, then we know, okay, it's gonna be a -1, right? So the problem is that how can we search, right? How can we prove that we can search only within the range of 10 to the power of 5, right? We have this kind of function, right? So we have x times w plus y times d equals to p here. Assuming, right? Assuming, let's say if the y is either equal or greater than w, okay? And if that's the case, so we can do some like transformations to the first formula here, which is going to be what? Which is going to be, I'll open this one here. I think we have x w, right, plus y dot d equals to p, right? And if the y is either equal greater than w, right? I mean, basically we're trying to prove it in a reverse way, right? So I'm saying that if y is greater than w, assuming we have and then we have like an answer, right, which is x0 and y0 that satisfy this equation, and right, and y is either equal greater than w. Okay, if that's the case, I can rewrite this function to what? To the x times w plus y minus w, right? Uh, Divided by d, right, equals to p. Okay, and then what do we have here? We're gonna have we have x we have x d plus y times d minus w times d, right? Okay. Yeah, sorry. So I think here I should be this one. Sorry, gonna be a plus wd, right? Wd equals to p, right? Basically, I'm rewriting this formula into this one. Basically, I'm just adding this kind of minus wd and plus wd here, so that we can have like something like this. So in the end, if we just rewrite this thing a little bit, we have like x plus d, right, and then dot w plus y minus w times d, right, equals to p. So now we have a w and d, and now we have a xy, x1 and y1, right? So basically x1 what I x1 plus y1 equals to what? Equals to x plus d plus y minus w, right? So these two things. And since d is smaller than w, right? I think we already it's one of the conditions I think in the problems. Uh, yeah, so d is smaller than w, right? So which means that this 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 d minus w is smaller than 0, right? Which means that x1, so x1 plus y1 is smaller than x plus y, right? So which means that x1 y1 is a better answer comparing with x plus y, because we want this xy to be as small as possible, right? So which means that whenever y is greater than w, right, we can always find a better answer, right? Which can give us like we can better answer for x and y, right? So this means what? It means that we can assume, right? If there's an answer for x and y, we can assume y is always smaller than w. Okay, y is always smaller than w because like I said, we can always transform this formula into this one, which means that we can always find a better answers as long as the y is greater than w, right? So then basically this one narrows down our search range, right? Instead of searching everything, we can simply use this w as upper bound to search y here. Yeah, I think that's everything we need to do for this problem. And as long as we can prove that, we only need to search from 0 to W. The rest is pretty straightforward. Okay, and let's do it. So to search that, okay, let's define some variables, right? N, P, W, and D, right? And to read in the values, we have N, we have P, we have W, we have D. So basically, we just need to search from 0 to W, right? 0, and then Y smaller than W, and Y plus plus. And if the P minus Y times D, right, is smaller than 0, we can simply break, right? Because Y's keep increasing, by the time uh, the P minus, because this P minus Y times D is like XW, right? As long as the other side is negative, since we cannot have a negative number of game, right, of winning games, that's we can simply break. And then in the end, we can simply do this, right? This output this one, -1, and then this one. Else, if we still within the, if the X is still positive or XW is still positive, we simply do this check, right? If the P minus Y times D do a modular of W, right, is equal to 0. Okay, that's basically, we have this kind of XW plus YD equals to P, right? So, and we're traversing, tried all the possible Y's from 0 to W, right, as we have approved there. And then for each of them, we check if the P minus Y times D can be divided by W, right? If it is, then with the first answers, we know we have find the best answer because one more thing is that the smaller the Y is and the better the answer is. Okay, because as long as we can find the first answer, starting from zero, that will be our best answer. Because since D is smaller than W, right? D is smaller than W. In order to make this X plus Y as small as possible, we need to make this Y as small as possible, right? So that the Y plus D is smaller, and the X, because this factor W is bigger, right? So which means that the smaller the Y is, the smaller the X will be, right? Because if we try to allocate more values from the left side to the right side, which means that we're gonna need a bigger Y to satisfy that condition, right? But if we are trying to move everything to this left side, because the factor of W is bigger, which means that we can use like a smaller value of the total value of XY to get the P. That's why the first time we find like a match, right? We find like a value, the P minus the Y times D can be divided by W. That's gonna be our best answer, right? And we can simply do another check, right? So now we have an X here. So X is gonna be what? P divided minus Y times D divided by W, right? And then the last check we need to do, we need to make sure the X plus Y is smaller within the range of N, right? Because because let's say we find the optimal solutions here, but this one is already greater than N, right? Of course, that will not be our answer either, right? So, but if it is, then we can simply output the answers here. Y, right? And then we have this kind of N minus X minus Y, right? That's a Z basically, and then we return from here. I think that's pretty much it is. I'm not going to run this problem because there could be multiple answers, right? And we could have a different answer as the examples, but I'm just trying to show you guys the idea here, right? So first thing is that we have to basically narrow down the search range, right, by uh, from 0 to W, right, based on our proof here, right, based on our proof here. And then next is that we since we know that we need to find the best the optimal answers here. We can simply start from the x from 0 for to search y, right? So the first number, the first y that can be divided this by w, that will be our best answer, best possible answer. And if that answer is still greater than n, then we know, okay, we will not find a better another answer for this problem, because while y is increasing, the x plus y will only get bigger and bigger, right? So that's why we can just use this first candidate to check to do the output. Yeah, and of course the time complexity for this one is going to be a 10 to the power of 5, right? Because that's the range of w here. Yep, I think that's pretty much everything I want to talk about for this problem. I would say it's a math problem, and it's very kind of interesting. Okay, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.